For the general term t of k plus 1 in the expansion of x to the a plus y to the power of n, the written in descending powers of x, the exponent of the variable x is. Alright, so to solve this one, we'll look at our formula sheet to give us the general term of the expansion, and it's over here. It tells us that when x plus y to the n is expanded, it equals the general term, the general term t k plus 1 is equal to nck x to the power of n minus k y to the power of k. But in our case, looking at the question again, we're given x to the a plus y to the power of n. So how do we do this? How do we deal with the extra a here in the x? Well, there's a simple trick. All we have to do is do a quick substitution. So I'm going to take my original equation up here. What I'm going to do is, instead of x to the a, I'm just going to put p. Here, I'll write that down. I'm going to say that p is equal to x to the a. Alright, so I took this and I said I'm just going to introduce a new variable p. I'm going to make it equal to x to the a, and I'm going to put the p in where the x to the a used to be, and it just gives me this. Well, this now follows this model up here. It's just there's a p there instead of an x, so now we can use this formula over here. This p should be over here. Because if x plus y to the n expands to this, then p plus y to the n has to expand to this, where p is in the spot where the x used to be. Right? So now I'm simply going to substitute this back in, x to the a for the p. So where the p is, I'm going to... So you see what I did here. Where the p was, I just substituted the x to the a. And now our final step is to expand this. So I can get rid of this bracket and this bracket. And I have that. T to the k plus 1 equals nck x to the an minus ax y to the k. And our question asks us for the exponent of the variable x. Well, there it is, an minus ak. That's a.